Hello, teacher Pali, Villanova student. Today I'm going to explain about the photovoltaic system design. Well, here we have the energy consumption for the control central unit in the community of Totogalpa. According to table 1, the energy consumption will be 21.74 kilowatt hour month or 260.20 kilowatt hour year. Well, we have chosen a solar panel 12 voltage and 200 watt. Well, the AC power PAC is calculated as follows. PAC equal energy watt hour between year between 8 day of peak sun. And this is PAC equal 227.76. To perform the energy calculation, a derived factor of 0.85 will be used. This derived factor is based on the following assumption. Here we have a little table and shows all the total about the derived factor 85%. The DC power PDC STC is calculated as follows. The PDC STC is equal 115.3 watts. Now we need to know about the number of modules. We have the formula is PDC STC between the power of module. Well, the number of module is equal of 0.75 is equal 1. We will use a module to control central unit. Power generated by this module. The DC power is equal power module by number of module. The DC power ATC is equal to 200 watt. The power generated by the photovoltaic system is 346.24 kilowatt hour month. Now it's necessary to calculate the temperature of the cell with that formula. The following table 2 shows the monthly energy generated by the photovoltaic system and the total energy for a year with DC power. It's equal to 100 watt, taking into account the temperature derived factor. Here we have the annual energy production of the photovoltaic system is 292.06 kilowatt hour by month. This is sufficient enough to supporting unit energy consumption. Now we need to know the size of the battery for the control central unit in the community of Totogalpa. We will use the solar insolation of the table 3 to know the number of no-sun days in the community. As a starting point for estimating the number of days as storage to be provided, consider figure 1. Two curves are considered for loads that must be satisfied during 95% of the 9,760 hours in a year, and one for less critical loads, for which are 95% availability is satisfactory. Well, here we have the figure 1, the days of storage based in peak sun hours. The battery sizing, the load is equal 0.71 kilowatt hour days between 12 voltage. It's equal, the load is equal 59.17 amperes hour days at 12 voltage. Well, August is the lowest insolation, so that will be our design month of 95% availability. It looks like we need about 3 days of storage. Now we use the formula usable storage is equal 95.17 amperes hour days multiply 3 days is equal 177.51 amperes hour. Now we need to know the factor of maximum discharge. We have considered 80%. Also the factor for the charge rate and temperature 97%. Now the battery capacity is for this battery is 228.75 amperes hour at 12 voltage. Well, about the energy consumption for the remote unit in the community of Tegucigalpa, we have this table, and this table shows the energy kilowatt hours days, month and year. According to the table 3, the energy consumption will be 1.35 kilowatt hour month or 16.20 kilowatt hour year. Well, we have considered solar panel 12 voltage and 15 watt. The AC power. Well, we are going to use the same formula that we used to calculate the calculate about the control central unit. Well, we have for the energy calculation, the refractor is the same 0.85 will be used. We have DC powered ATC 9.35 watts. Well, we need the number of modules. We have one module. We will use one module to remote unit. Power generated by this module. DC power is equal the power module multiplied the number of modules. We have 15 watts. The power generated by the photovoltaic system is equal 25.97 kilowatt hour month. Also, we use the same formula to know the temperature of the cell. Well, the following table shows the monthly energy generated by photovoltaic system and the total energy for a year with this power 15 watts. Also taking into account the temperature and the rate factor. The annual energy production of the photovoltaic system is 21.83 kilowatt hour month. This is sufficient now supporting the unit energy, the remote unit energy consumption. Well, also we need to calculate the size of the battery for the remote unit in the community of Tegucigalpa. We use the same formula for the control central unit, and we have allowed 3.33 amperes hour days at 12 voltage. Usable storage also is 3 days, and usable storage is equal 9.99 amperes hour. Using the same, the factor for maximum recharge and the factor for the charge rate and temperature, we have the battery capacity 12.87 amperes hour at 12 voltage. Well, this is all. Thank you very much for your attention. I hope that you can understand me, and please let me know if you have any question about that.